The video is on frequency response of an LTI system. Before moving to the topic, let us know about the transfer function. The transfer function of a system, it is defined by the output divided by input. Here the transfer function is denoted by h of e power j omega, which is equal to y of e power j omega divided by x of e power j omega, where the y of e power j omega, it is the output that was modified by the given input x of e power j omega. Both the terms x of e power j omega and y of e power j omega, they are dependent on the frequency. So hence the transfer function is also called as the frequency response of an system. Let us consider an causal stable LTI system whose input x of n and output y of n, it is given by the relation y of n minus 5 by 6 y of n minus 1 plus 1 by 6 y of n minus 2 is equal to x of n. Let us determine the frequency response of the system and the impulse response h of n of the system. So as we saw in the previous slide, the frequency response is the transfer function of the system. So first we determine the transfer function of the system. So given equation, that was a difference equation which was given, and on taking the Fourier transform on the both sides, for y of n, the Fourier transform can be written as y of e power j omega. So y of n minus 1, so y of n minus 1, so we are substituting e power minus j omega y of e power j omega, and plus 1 by 6 y of n minus 2, so here it is y of n minus 2, so we are substituting e power minus j2 omega into y of e power j omega. If the question has y of n minus 3, it will be, instead of y of n minus 3, we have to substitute e power minus j 3 omega into y of e power j omega. And here x for x of n, x of e power j omega, take y of e power j omega as a common things, and have y of e power j omega divided by x of e power j omega, which is the transfer function and which is also called as the frequency response of the system, which was given by 1 divided by 1 minus 5 by 6 e power j omega plus 1 by 6 e power minus j2 omega. So on taking the poles of the previous one, we have 1 divided by 1 minus 1 by 2 e power j omega, 1 divided by 1 minus 1 by 3 e power j omega. So we have to calculate the roots of the difference algebraic equation on the previous slide. So taking the partial fractions to find the coefficients of a and b. So we have a divided by 1 minus 1 divided by 2 e power minus j omega plus b divided by 1 minus e power j omega divided by 3 e power j omega divided by 3. So for calculating the coefficient a, that particular term into h of e power j omega, we are calculating for a. So substituting e power minus j omega equal to 1 by 2. So on substituting, we have a equal to 3. So we are calculating for next b term. So b divided by 1 minus 1 by 3 e power j omega into h of j power omega. We have in h of j power j omega, we are having 1 divided by 1 minus 1 by 2 e power minus j omega into 1 minus 1 by 3 e power minus j omega. So here we have multiplied with the same poles. So 1 minus 1 by 3 e power j omega, and denominator h of e power j omega 1 minus 1 divided by e power j omega, they both cancel each other, and we have to substitute for e power j omega. So we have 1 minus 1 by e power j omega equal to 0. We equate the terms. So while equating that particular term, that is 1 minus 1 by 3 e power j omega equal to 0, we have e power minus j omega is equal to 3. So on the whole we will have only 1 divided by 1 minus 1 by 2 e power j omega. Instead of e power minus j omega, we have to substitute 3. So 1 divided by 1 minus 1 by 2 into 3, so it will be 1 divided by 1 minus 3 by 2. So on equating, which will be given b is equal to minus 2. Write on the coefficients. So h of e power j omega is equal to 3 by something term and minus 2 divided by something term. So taking inverse Fourier transform for this particular term, this is in related with the generic equation. So that particular coefficient divided by 1 a power n into e power j omega. So equating with that term, instead of a power n, you are having 1 by 2. So 1 by 2 the whole power n into u of n. 3, it is a common coefficient for the first term. Minus 2 into, instead of here it is a power n e power minus j omega, you are having 1 by 3. So 2 into 1 by 3 the whole power n u of n. That is a generic general equation. So this is how we have found h of n. So finding the transfer response is the frequency response of a system, and impulse response is the taking the inverse Fourier transform of the h of e power j omega. That is the frequency response of the system. Thank you.